let's do this. In the poll, and then I'm going to reopen it. And I'm having problems with my polling. I was going to attempt to see. Okay, good. I've got it working here. Now we got to pull out on the screen. Go ahead and let us know kind of where you are in your spectrum of cloud. Are you pretty savvy already with cloud, or maybe you're just new? Juniper's doing, or if you're like me, you just like clouds because they bring rain, and it's a lot of fun. Looks like we've got a pretty good mix, good participation there. I see we got more than half of the folks are willing to say where they are, and Gordon and Mark look like we got a nice split between folks that are pretty savvy on cloud and just want to know Juniper, and folks that are pretty new to cloud. One brave soul that just likes clouds because they bring rain. I'll go ahead and move that out. So what we're here for, of course, is preparation for the JNCIA cloud certification. And part of Open Learning is an exam voucher that allows you to take the cloud certification exam for free. But you do have to do a couple of things to earn that voucher. You have to download and spend a minimum of 5 hours viewing the course materials. And you also have to take the JNCIA Cloud practice test at least once. Both of those are available inside of Junos Genius. And if you are registered for this Open Learning session, but haven't accessed the materials, just be sure to send us your Junos Genius user ID to junos-genius@juniper.net. And I will say we will only provide those materials to folks that are actually registered for Open Learning. So if you did not register through the Juniper Learning Portal and receive an official confirmation and the welcome email, we will not provide access to the Open Learning materials. So that's just a note. We've seen a few requests today, folks trying to just go straight to the materials and free voucher, and we need you to actually register for Open Learning first. So the voucher will be good for 90 days. We'll distribute those at the end of the Open Learning session. I'll run a report to show who's actually spent the minimum of 5 hours on the materials and who's done the practice test. That voucher will be good for 90 days, and then you can use it at person view at any time. So make sure you meet those two requirements. That's how you earn the voucher. And at this point, I'm going to go ahead and turn it over to Gordon and Mark to really go through the best part of today's session, which is all the good technical goodies.
Hey Lawrence, thank you very much for the introduction. Hello everybody, my name is Gordon Mosley. I'm with the Education Services Department at Juniper Networks. And assisting me today, along with Lawrence Rust, is a gentleman named Mark Postma, who's the actual developer of this course. He's done a wonderful job, and he's here to answer your questions. Your job is to, of course, you've already accessed the material for the course, you've studied it, you're ready to go today, and you're going to operate this chat window, right? You're going to ask questions, you're going to interact, you're going to share your experiences with us and help everybody be educated about cloud and cloud infrastructure. So we're here today with this Juniper Open Learning event to prepare you for the Juniper Network Certified Internet Associate Level Certification for Cloud Technology, the JNCIA Cloud Certification. So this certification is an entry-level certification for a brand new cloud certification track that we're developing beginning at the end of last year and going forward into 2018 and beyond. There's a certification exam I'll discuss with you in a few minutes that you have to pass to obtain this certification. And this is the very first certification that you take in the cloud track. And so this is a springboard to more specialist, professional, more advanced level cloud certifications. The certification is valid for 3 years. I have to talk very fast, right? We have 90 minutes to get through a lot of material. So, put your, listening ears on, right? So to get certification, you have to take the JNCIA Cloud Certification Exam. It's available at Pearson VUE testing sites all around the world. You have 90 minutes to take this exam and answer 65 multiple choice questions. And at the end of the exam, your pass-fail status will be displayed for you. So very similar to any other technical exams you may have taken, kind of in a Pearson VUE setting, right? The certification exam is not easy. I need you to prepare. It's not an exam you're going to be able to go in and just kind of guess, and because there's general cloud exam topics, general cloud concepts and information, but there's also Juniper specific cloud technologies and architectures And so you'll need to know a lot. So I need you to prepare. Take advantage of the materials that are being offered to you through this Juniper Open Learning process, and you will be successful, or you should be successful on the exam, right? So again, I mentioned that the JNCIA Cloud is the very first certification that is available to people who are trying to progress through the Juniper Cloud certification track. And so we are at the associate level trying to get you the JNCIA Cloud certification, but there are also specialist and professional level certifications available through this cloud certification track. So this is just a start for you, and just keep going. Keep learning more about Juniper technologies, right? So let's look at the materials, right? You're in open learning. What's the benefit of that? The big thing and the source of most of your exam preparation, and your exam questions are going to be the Junos Cloud Fundamentals course. This is normally a 3-day course. It's a series of 10 modules we're going to go through. We have 3 sessions together. We're going to start today with Module 2 and go through Module 4. But it's a day's worth of training that I have to get through in 90 minutes, so I will talk fast, right? You're going to need to read over this information. What I want you to do as I go through this is utilize that chat window to answer questions and let's help explain the topics, flesh out things that people might need a little more depth of understanding on. And then the next session we'll go through the day 2 modules, and then our last session together next Wednesday or whatever day it is where you're participating in this event from. We'll go over the last 3 modules, right? So you'll have a homework assignment before we get to next week. Read chapters 5, 6, and 7 in the Junos Cloud Fundamentals course that you are accessing through Junos Genius, right? So you get access to that course, normally a 3-day course. We also have access to these JNCIA Cloud Content Review live sessions. That's what we're doing right now. Interact with me, with Lawrence, with Mark, the courseware developer. So let's just try to deepen your understanding to help you be successful and when you go to take your JNCIA Cloud certification exam. Okay. There's also available to you in Junos Genius, and as Lawrence mentioned, this is one of the requirements for you to qualify for the free voucher for the exam, is that on Junos Genius there is a JNCIA Cloud practice exam that covers a lot of the same concepts and topics that you're going to need to understand to be successful on the live exam. If you pass this and get a great score, I can't guarantee you will pass the actual exam, but it's a good gauge of kind of where you are, understanding-wise, and what areas you need to kind of go back and review in the Junos Cloud Fundamentals course, right? So we also have a forum. Now, after we get done today, I won't really talk to you until next week, so we don't have any interaction. So to fill these gaps, we have a community that's created in our JNet forums. At forums.juniper.net, there is a private forum that has been created just for open learning participants, right? So you go to forums.juniper.net. You have to create an account to access the forum. So you create an account, nothing hard to do. I can do that. Here's my username, here's my password. When you get that account created in the forums, you need to email your username to education-services@juniper.net. You see, this is a private forum. So you have to get access. You have to be given permissions to view this forum. And so after you create your account, email your username to education-services@juniper.net so we can give your account permission to access the open learning forum. Then when you go to forums.juniper.net and log in, there's a forum private for us to ask questions, to share our experiences, right, to better prepare ourselves for the JNCIA Cloud exam, right? Do that. And then look, as you go through this, there may be some concepts that you really don't quite completely understand. I took my Junos JNCIA Cloud certification practice exam. There's a couple areas I was really weak on. So we have additional resources, right? Use our product documentation. Use our, our forums, right? We just talked about the forum. We have tons of product documentation that can help you, hear a different point of view about a particular topic, maybe a different use case, a different example. It may help something click in your head, right? So on we go, right? That's all I've got. So welcome to Juniper Open Learning. I'm Gordon. We have Lawrence. We have Mark here to help us out. Use the chat window. Ask some questions. So let me go load up chapter 2 here. This is our first chapter that has, the first chapter 1 is an introduction. We can kind of, hi, good to meet you, I'm Gordon, right? So now we're going to go to chapter 2. I'm going to talk fast. We're going to talk about cloud components. We're going to talk about underlay networks, overlay networks, different types of cloud architectures that you may come across and need to work with. And we'll also talk about different types of services that cloud providers offer to customers, right? So here we go. We'll start out with a definition of what cloud networking is. There's actually a standard definition. The National Institute of Standards and Technology came up with a definition for a cloud, right? It is a shared pool of resources that can be used by multiple customers, right? That's what a cloud is. Think about a big data center that you may have built for a private company. Well, let me build a big data center and let multiple companies share this pool of resources, this network, this storage, this compute, pool that I have. I want to share that among multiple customers, and I want to be able to dynamically automate the creation of services and applications that I can offer to my customers, right? I am a service provider. This is what I do. I am a cloud service provider, right? And I build clouds inside of data centers. Not every data center is in a cloud. It has to operate as a cloud environment does. So read that definition. Know that definition for your certification exam, right? That's what we want to do. Now we're going to talk about a couple different things that you will have to have in a cloud. I need a network, right? I need switches, I need servers, I need storage, I need the physical kind of components. That's called your underlay network. The things that you always saw physically in a data center. But what I'm going to do in a cloud environment is on that underlay network, I'm going to build overlay networks, overlay tunnels that are used to connect customer applications together. So the customers will use the underlay network, but I will create an overlay network, essentially a private network on that underlay network for each customer. And I'll separate their traffic using, the virtual machines that customer A spins up in my cloud environment. I'm going to build a virtual network that connects all those virtual machines together so their application works. And I'll build little tunnels between the different virtual servers using VXLAN or using MPLS. And I can do this dynamically. I can spin these things up, spin up these networks, spin up these VMs, spin up this storage, on the fly. Nobody has to manually do anything. I push a button. Isn't that cool? So here's an underlay network, physical components, racks of servers, switches at the top of the rack. Let's connect those switches together at the access or distribution layer. So whatever your architecture is, right? I need it to be highly available, highly redundant, low latency, very efficient data center network, right? I always built these. This is how it works, right? And then that underlay network, how are you going to connect the servers and the switches? Are you going to do it in a layer 2 fashion? So they learn and forward things based on MAC addresses, or more commonly, are we going to build a layer 3 connectivity so each device has an IP address and we route traffic to the different components in this cloud, right? So that's my underlay network, right? And then once I get that built, regular stuff, cable it, plug it in, all that fun stuff, rack, stack. Now on that, I want to dynamically be able to, for example, on these 3 racks of servers here, wherever the red slash is, right? That's a server that's running a virtual machine for customer X's application. And they run 3 virtual machines that are actually on 3 separate physical hosts on my network. I need them to connect. That web server has to talk to that database and then forward things to the email server, right? For the application to work. So I need to dynamically spawn these virtual machines and dynamically connect them together so they can communicate, right? On probably a layer 3 fashion. So we're going to use tunneling technologies to dynamically build networks on top of the underlay network. That's what the overlay network's all about. That allows the customer's applications to communicate and to function. No matter where the virtual machines get spawned up, I can dynamically create those tunnels. It's magic, right? Let's look at some different cloud architectures, right? Public cloud, private cloud, hybrid cloud. Let's kind of look at these, right? First thing, a public cloud. This is what I always think about when I think about cloud. This is kind of the true definition of a cloud environment, right? Things like Amazon Web Services, Microsoft Azure. Those are the 2 big ones I've always heard about. But we run our applications in AWS, right? That's where we run them. And this is a public cloud that you can run your applications in there too. You just write it to run in that environment, right? Spin it up dynamically. Hey, that data center's down. Let's spin it up over in this other data center. Amazon's got a bunch of them. Right? Public clouds, anybody can use it. I access these over an internet connection. Isn't that something? Right? Here's Amazon Web Services. Hey, here's my 2 virtual servers. My web server and my database server for application X. We run it AWS. And they give us an IP address, so we put in www.mycompany.com, that IP right there, sir. That's how you get to it. And we've got another IP they give us so I can connect in and manage and configure my little private cloud here. Isn't that something? I even put a little firewall in there. Right? Now, hey, let me go back a slide. You know those two virtual servers? Well, they're Windows servers, or they're a supported version of Red Hat or something. I got to buy a license for that, you know? And cloud providers have different license models. Depends on how what type of applications you're running, how you access them, how long do you use them, how much data do you move. Right? Or, hey, no, wait, I already have a license for that. I bought a Windows 10 license. I just want to run it in AWS. Okay, cool, you can bring your own license. That's fine. So, you know, you can, that's a money. That's a financial transaction, right? That doesn't bother me. All right, or a private cloud. That's kind of cool. Why would I do that? Well, my heavens, we have a data center, you know, and I like the way these cloud things function, that we can dynamically spin applications up, but I want to do that for my own internal employees. I'm a government agency. I can't shove my private data out there in a cloud. Are you crazy? But I like the way it works, so I'll build my own, right? We can do this. It's a private cloud, right? Accessed over a private connection in our network type stuff, right? Our internal, we can do this. Why? Because they got a bunch of sensitive data. I don't trust those weenies over there at that cloud provider. What are they going to do with my data? They might sell it, right? We'd be sunk. So, you know, maybe we build our own cloud. We run our accounting applications in here, our HR applications. Right, our web app, we run it in here. You need some more web app. We have a big promotion going on. We need how many more web servers? Spin them up. Right? Isn't this cool? Cloud. Love me some cloud. Right? Hey, I used to support web developers when I was a young man, and golly, boy, it was tough back in the day. If hey, we've got a new project, we're going to start. Oh, okay, well, we need to buy a couple servers. We need to buy a couple operating system licenses. We wait for the server team gets them first. They've got to put them together, rack them, install the OS, get all their management tools on there. Then we got to go get network team to make the ports hot, put them on the right VLAN, give us some IP addresses. What? The database team? Holy smokes, the Oracle guys? We got to go talk to them. That's another meeting. It'd take a month to get an application set up so we can start work. I can't do that, right? I'm stuck in the mud over here. Everything had to be manually configured. It takes forever. I'm losing money. How much do these developers make an hour and they're sitting around? When we tear it down, holy smokes, what are we going to do with those servers? You know, so no, in the cloud world, what do you need? You need a couple of servers. I just spin up a couple virtual machines in the cloud. What, a database? Okay, cool, we've got that. Storage, huh? I've got it. Right? It's just much faster time to get going. That's the whole thing about this. I don't have to change my underlay network and everything. I'm just spinning up new virtual machines on top of the same underlay network. We've been spinning virtual machines up all year. Right? And then we just push a button. I'm excited about this cloud stuff. Right? So, you know, it's all automagic. Man, no, what do you need? You just fill out a form. Email it to. We'll have it set up by after lunch if that's okay. You know, you guys can get going. Awesome stuff, man. And then when you're done, you guys are done with that? Hey, okay, cool. Well, what I want you to do is, does it work? Do you like how it is? Okay, cool. Well, hey, why don't we just save those virtual machines and we'll just copy them over to the production cloud. And then spin them right up. We're ready to go. I don't have to go, now we have to buy the servers that we're going to put in production. And also in staging. And also in test, right? All these levels. In the application life cycle, right? Holy smokes, I can push buttons and do that here, right? And then when we're done, we can just shut those virtual servers and dev down and somebody else can start another project with those resources. Automatic is the whole cool thing about this, right? Fast resource access, all right? Hybrid cloud, look, again, we get back to the sensitive data kind of thing here. People are sensitive about sensitive data. If that data gets out, I lose my job. Those credit card numbers, those medical records, I can't shove that out in some public cloud. What are you thinking here? You know, I've got a mortgage. So sometimes you may end up with some kind of a hybrid environment where in my public cloud, maybe I put my web front end to something, right? And so we can spin that up, all kinds of front ends, but that front end actually calls back to some private database on our private cloud. Or some other piece of the application that can access the data locally, we can have somebody leaning forward in his chair keeping his eyes on that web server or on that database server, right? So you may end up with some type of hybrid. And so there's a whole thing about these data center interconnects. You know, my application actually runs in a couple different data centers in kind of a hybrid cloud environment. And so some of the pieces have to communicate over this, you know, data center interconnect between my private cloud and public cloud. We IPsec that, of course, security folks like we are. Awesome stuff, man. Awesome stuff. Scalable about this whole cloud thing, right? Let me go back a slide. Once I figure out how to do this once, I can run more front ends and more public clouds all around the world that can call back to my private cloud. So once I get good at this, it's real easy to replicate this cloud stuff, right? And that's kind of the cool thing about that. So there's public clouds that I access over a public connection, and those resources in that public cloud are shared amongst multiple groups and organizations. Or a private cloud that operates like a cloud, but it just runs my stuff. We access over a private network, private links type stuff, right? Or maybe a little bit of both, right? Different services available through cloud providers. What's this all about, right? Is that I can provide a lot of services in a really rapid fashion to customers. Different services. So let's look at some of these, right? First one we look at is infrastructure as a service. You'll need to know these for your exam. I'd pay attention to them, infrastructure as a service, what's that mean? Well, I'm really going to give you nothing but a virtual server. You will have to, here, you come to my cloud.com page, you say, well, I need 2 servers, right? Well, what kind? Well, they need 8 CPUs, I need 32 gigs of RAM, I need this much storage, I need this type of network. Oh, okay, so you'll go fill out a template and you hit submit, and they will literally, okay, well, here it is. Now, you, customer X, have to install the operating system on there, then you install your application. You do more of the stuff yourself. And I'll sell that to you. You tell me what you want. That's called infrastructure as a service. His cousin, platform as a service, is essentially the same thing, but on top of this how many CPUs? I'm going to put the operating system on there too. What, you need a Windows server and 2 Red Hat Linux servers? Cool, I'll have the OS on there. And I turn it over to Gus here, and he puts his apps on there. So that's called platform. So it's the virtual machine with the OS, platform, as a service. You need to know that, right? Software as a service. Not only do you get the virtual machine with the operating system on there, the applications are on there too. So the web server and your, Oracle database, it's already on there. That stuff's on there. You now configure Oracle, and you configure that web server the way you want it to work. You put your web pages on there, you permission it, right? You install your database tables, right? You do that. That's software as a service. The software is there. The applications are there, right? Here's another example. Payroll service. Hey, we've got PeopleSoft. We've got, I don't even know. Salesforce.com, Office 365. All this stuff runs in clouds, everybody, right? And I sell this. So you go to our website and you say, well, I need payroll, so what application do you want? You hit the drop-down there. Oh, payroll. We need payroll. How many people are going to... Well, we've got 500 folks in accounting. We're a big shop over here. They want muffin and break. And then, okay, cool deal. Have 500. Boom, and here you go. Here's your accounts. We'll email these out. And it's spun up in minutes, folks, right? Can you imagine having to do something like that in the real world? Oh, my goodness. We're going to have some meetings here. No, just fill out the form, boom, spun up, ready. Right? Redundant, highly scalable, amazing. Cloud. Right? So that's this chapter. Kind of, what are cloud components, right? We have an underlay network that we've always had in a data center, right? But how we use that with these new overlay concepts and spinning up virtual machines and dynamically networking them together, cloud, right? And then we talk about private clouds, public clouds, hybrid clouds, different flavors of clouds. And different types of services, platform as a service, infrastructure as a service, and kind of know those definitions, kind of know the difference between them, right? Hey, congratulations, that's Module 2. Read it again, right? Read it again. Let's go look at Module 3. Isn't this fun? It's fast, man. Let's see what we've got. Module 3. Here we go. Come here, you. Module 3. Open Learning, Open Forum. I apologize. That's from another class. I didn't read my documents closely enough. Let's try this again. Let me see. Chapter 1, Chapter 3. Here we go. I've got the right one. I hope. Let me know if I don't. Yay! Module 3 of the Junos Cloud Fundamentals course, Implementing Cloud Networks Using Juniper Network's Virtualized Platform. It's a good one here. We're going to learn about some Juniper technologies. We're going to learn about the VSRX, the VMX, the NFX platform, We're going to talk about another thing called the Juniper Cloud Connector. So let's get going pretty fast here today, right? So let's start first looking at Juniper Networks virtualized platforms. The one we're going to start with is we're going to talk about just virtualization in general. Where did this all get started? Look, back in the day, you bought a $10,000 server from HP or Compaq. You racked that $10,000 server. You installed some operating system on there and some application like an email server. And that's all that server did, 10 grand. And then, that thing's running at what? 8, 10, 12% processor utilization? So I bought 90% more than I'm actually using? That's a waste. And we built data centers, rows of racks full of those things, right? Waterfall of money. That doesn't work. That's a bad business model. So somebody came out with a way, well, my heavens, we have so much more hardware than we can actually use. How can we use it more efficiently? Let's build something called a hypervisor, where I can virtualize that hardware. That CPU, that RAM, I can virtualize that in software and install an operating system on that virtualized hardware. And then so I can install multiple guest OSs onto this physical server because this hypervisor can make it look like there's multiple virtual servers that software is running on, those OSs are running on. Awesome. So on that one physical server, instead of having one operating system and one application, I can spin up multiple instances of a guest operating system and multiple applications and better utilize those hardware resources. Changed the world. Changed how data centers were structured and used, right? Amazing stuff. And that's great, right? Those hypervisors emulated the hardware. The guest OS had no clue. I could move the guest OS to a different server in the data center, different data center completely, right? Move things around, and the OS had no clue. Because the hypervisor just, here's the hardware, bud. I'll really talk to the physical hardware. Don't worry about it. Awesome stuff, man. Awesome stuff. And that's great. And that worked for servers for years. Windows servers, Linux servers, whatever apps you wanted to run on those. But networking hardware was different. Networking hardware didn't run on standard x86 processors. Or some of it may have, but there's special ASICs, special chipsets to give special functions to these networking devices that regular operating systems can't do. So I can automate the server piece, but automating the network piece, spinning up virtual firewalls, virtual routers, that's tough to do, right? Especially if I want advanced features and functions and throughput and performance, all that kind of fun stuff. So to help us out, Juniper has come out. We've always had a product called the SRX. So it's our line of security platforms. Traditionally kind of like firewall-y type stuff, natty, IPsec stuff, good stuff, security stuff. We would sell you an SRX. We have completely virtualized the functionality of a physical SRX platform inside of a virtual machine, right? What does that mean? Well, on standard x86 servers that you're running your Linux OSs and your Windows servers on, I can spin up a virtual SRX, and I get full functionality. There is nothing different about the functionality of a virtual SRX and a physical SRX platform, right? I can spin this up in my data center and use it to secure virtual machines or anything in my data center. It's a fully functional firewall as a virtual machine. That's what the VSRX is all about. You need to know what it does, right? So, and it's scalable, right? The minimum configuration, it actually is 2 virtual machines. There's one virtual machine that's spun up for the control plane. There's another virtual machine that spins up for the forwarding plane. It kind of runs the control plane runs kind of as a nested VM in the VSRX kind of image. And I can architect this based on performance, right? I need a minimum of 2 virtual CPUs, one for the control plane, one for the forwarding plane. But I can add more virtual CPUs to this virtual machine and increase performance. So I think I'm going to show you a table here in a couple of Mississippi. Here's the virtual VSRX 2.0, right? And here's kind of the architecture. Here's my control plane, and here's my forwarding plane, and all this kind of fun stuff. And all the features, the exact same features you get on a physical SRX device, right? And here's the performance levels, right? I said a minimum of 2 CPUs, one for the control, one for the forwarding plane. I get this much firewall throughput, this much IPsec throughput, this much IDP throughput, this much whatever, sessions, but I can scale it up to 16 virtual CPUs, and I can get 100 gig throughput now. So I can have virtual SRX service offerings for my customers. Hey, customer X, you want a firewall? Hey, we've got a Juniper SRX firewall you can spin up in your cloud environment. Cool. Secure your servers. How much throughput do you need? What type of traffic? You got IPsec? Okay, well then we need to give you the model of VSRX that has, 8 virtual CPUs. So you can reach that level of throughput. So they can just hit the drop-down menu. I need this type of firewall with this type of throughput, these type of requirements, boom, and I spin up the correct VSRX image for them, right? Isn't that cool? In my cloud. And that's the idea. Now, look, there's a couple things here about architecture and some things you want to think about when you're trying to build your cloud environment is that I'm spinning up these virtual machines, especially network-based, like an SRX-type virtual machine. It's really going to receive and probably process a lot of traffic. And I want this to be done in the most, of course, efficient manner possible so I can get higher performance and charge more money and all this good stuff. And so, normal way, a packet comes in, this is a VSRX. It's running on a physical, Intel-based server. It's got a network card. So traffic for that virtual machine firewall comes in, and, it's on a NIC. The hypervisor's got to figure out, holy smokes, well, which, virtual machine is this for? And then I can, send this over to the processor for that, virtual CPU for this. It's a slow process, man. I'm busy around here. So the newest way to do this is something called single root I/O virtualization, where it literally allows the virtual interface on a virtual machine to share a space of memory. And so when the packets come in, I can write that to that virtual memory space without having to involve the hypervisor. It's less steps, and it really increases throughput. Like if you want to get 100 gig on your VSRX firewall, you need to make sure that your hypervisor and your physical servers support this SR-IOV infrastructure so we can bypass the hypervisor for network-intensive applications. Makes them perform a heck of a lot better, right? That's the idea there. More of those virtual machines will make you smile. That's a great thing when I look at those. But what I'm looking at now is maybe even a better solution. Something called containers. And there's a container version of the SRX platform. So let's kind of look at what a container is all about, right? So we've traditionally virtualized things. Here's my, my physical server, and I've got let's say Linux on there. I've got a KVM hypervisor. Now, so I'm running, Linux virtual machines that I've got spun up. And then I do that so I can run a web server, an HTTP server, right? Or a, a database server. But look at all the underpinnings, all these libraries, the printing library, the graphics libraries, the guest operating systems, this hypervisor. That's a lot of RAM, that's a lot of CPU, that's a lot of storage required. Let's come out with a better way. They have these things called containers now. And on that physical infrastructure with this Linux operating system, instead of installing a hypervisor, I'm going to install something like Docker. It's a container-based way of virtualizing services that eliminates the need for the guest operating system. And man, what's a Windows server, Windows 10 server, Windows 10 server image? What is that? 400 gigs? How big is that image? 400 gigs I've got to spin up in RAM to run a web server? If I can do the same application inside of a container, I don't need that guest OS. That's a lot less RAM, that's a lot less storage, it's a lot less. So I can run more applications on the same infrastructure because it requires less resources. So containers are the new, fastest way or most efficient way to offer applications inside of a cloud environment. The thing is, you have to make sure your applications support running in containers. And as that, method grows and grows in popularity, more and more applications, of course, will be able to function in that space. So we have, again, a container version of SRX. So if you're using Kubernetes and you're spinning up containers and applications in containers, you can spin up an SRX in there too while you're at it, right? So, it's just, look how quick they boot. A virtual machine, how long does it take to boot a Windows 10 server? I'll be back in a minute, right? I'm going to go get some lunch. I'm going to stop by and talk to Sally, get a soda on the way back into the data center, and hopefully man, you can spin these containers up less than a second. A lot less RAM, a lot less CPU. Look how much more I can put on a physical server. Instead of dozens, thousands, a lot less resources involved, right? So maybe I could do what's called microservices. Hey, if it's just a container app that's going to be 100 meg RAM, that's it. Oh man, let me spin that up. I'll configure that one to do NAT. I'll configure another one to do IPsec. I'll configure another one to do IDP. I'll configure another one to do some other function. And I'll let the customers go in and pick from a menu. I want this, and I want that service and that service. And based on what they pick, I'll spin up these little micro container applications. It just gives me a lot more flexibility because I have so much more efficient use of my resources. If I try to do that with virtual servers in a hypervisor environment, I'm going to have to charge them more. Right? I can compete here with these containers. So that's kind of what that's all about, right? And again, from the Department of Redundancy Department, here's, kind of doing, hey, you want, 150 instances of firewall So that's 150 instances of VSRX configured for firewall, 50 instances configured for IDP, 200 instances of. Look how much, 400 virtual CPUs, 1600 gig of RAM, 6400 gigs of storage. Look what I do with that in containers. Same thing, 200 of them, right? 15 gigs of RAM, 150. Look, my heavens, factors of 10 almost, right? Look how quick it'll boot, right? My goodness, I like these containers, right? I have to talk faster here. So the benefit, just, hey man, I use my resources better. It's faster, right? The only drawback is I have to make sure all the services I'm currently offering with my present model, I can offer as many of those services as I can in a container environment. It'll all run in my data center. It's still the same network. I don't have to change the underlay network, right? So just faster and better and prettier and everything. Okay. We also have a virtualized version of our MX platform, Juniper's MX routers, like the market leading edge router, right, in the world. And so it's just widely deployed. And so, but it's always been a physical device, a physical platform that you would buy from us, a chassis with Junos, in specific chipsets, the Trio chipset specifically for MX routers. Juniper proprietary ASICs that give those devices such great functionality. We've actually ported that over into a virtual machine platform called the VMX. The exact same functionality as a physical MX platform, and I can spin this up in a cloud environment. It's actually two virtual machines. There's one virtual machine for the control plane, there's another virtual machine for the forwarding plane, and it connects together using an internal link, just like a physical MX does. If you look at a physical MX platform, this is an MX80. Right? Inside there is a control plane, there is a forwarding plane, there's an internal link that connects them together. We just virtualized that, right? That's what we've done. And so, on a standard x86 server, right, you have in your data center running every other virtual machine you've got, let's spin up one of these virtual MXs. Heck, it's a virtual machine, let's spin up some more. Why not? Push the button, right? And so if customers need routing services, hey, I'm trying to connect, this data center to my data center in Sao Paulo over there. That's going to require some routing. Maybe we want to do MPLS connectivity between there. So let me get a virtual MX going. I'll configure it. I don't need to buy the physical one, so I can sell advanced routing services to my customers in my data center in my cloud. That's pretty cool, right? Couple versions. There's a light mode, and this is going to be based on what type of throughput does the customer need. With this light mode, the customer can shove about 100 megabits per second through this platform. There's also a performance mode that gets you up to greater than 3 gigs with that single root I/O virtualization. Remember, we want to bypass that hypervisor for network traffic. That gets me a lot greater throughput. So just a couple different flavors you can offer. Based on the same functionality, it's just what performance levels do you need? The light mode or performance mode, right? It runs on all kinds of hypervisors, right? If you've got a hypervisor, it'll run on it, right? So it's very flexible there. And again, this is something you would spin up dynamically. That's what this is all about. In my cloud, I don't know how you spawn it up. Oh, we've got a scripting, we've got a custom-made application, or we're using OpenStack as our orchestrator, right? Network, compute, storage, spin up. And I'll have OpenStack do this for me, right? So that's the idea of this, is instead of having to rack and cable and configure manually, I want to spawn up these virtual machine images of an MX full service, full functionality MX router in my cloud. Start selling network services. Right? Another platform we have, and I'm not going to hit this one too much. We're going to talk about this in a later module we'll get to either next week or the week after. We also have a platform called the NFX250. This is designed to be a customer premise equipment platform. Let me take a look at the next slide here and see if I can explain it a little better to you. Here's the insides of an NFX250. It's a standard x86 Intel-based platform. It's a physical device, right? An NFX250. Standard hardware, Intel hardware. Here's how much RAM. Here's how much all this kind of business. And it has a Linux operating system installed on it with a KVM hypervisor pre-installed. And so what I can do, this is my customer premise equipment device. Customer says, hey, I need a device. We want internet access, or we want connectivity to this remote location. I can drop ship this out, have it to you tomorrow. It's an open source platform, and I can spin up Juniper virtual machines on here. Like, what do you need? Firewall services? You need NATing? You need firewalling? You need IDPing? You need routing services? Let's spin up a virtual MX on here. You need to build an MPLS tunnel to your Denver office from Sao Paulo? Hey, we can do that on here. So it's an open platform, standard x86 Linux KVM hypervisor running, and so we can install not only Juniper virtual machines on here, but also any type of third party. Hey, you need a load balancer? See that company, see if they've got a virtual machine. We can dynamically push that virtual machine onto this platform. So it's an open platform that I can dynamically provision services to that remote client without having to roll a truck, right? All I need this thing to do is connect back to the service provider network, and I can instantiate whatever virtual machines I need to in an automated fashion to give that customer whatever service level they need. That's the idea of this platform, okay? So it's a cloud-based type of platform. In public clouds, where do I access these Juniper, MX, SRX? Where are these available? In any kind of cloud, any type of Microsoft cloud, Amazon cloud. So let's say you have an application. Well, we run it in AWS. It's run. Well, hey, do you understand that, between your web server and your database server, those virtual machines, Amazon Web Services may sell you a little firewall. Why don't you take a look at using the Juniper VSRX to do that? It's available in the Amazon Web Services, cloud. Use that instead of theirs. It gives you better features and better functionality, better performance, right? Your job's on the line for this, right? So, it's available in these different clouds already. Just pick it from the list. Right? Again, here it is again, right? Here's my web servers. Here's my database servers. I want to put a virtual SRX in there. Secure that east-west and that north-south traffic, even the management traffic. Put that stuff in separate zones, man. Firewall it, NAT it, secure it, IPsec it. Right? Here it is. Hey, look, I'm on Amazon Web. This is their website. I've been there before, man. Hey, networking, pick that. Pick that virtual SRX right there, senor. It's good stuff. You need routing, get that virtual MX going. All right, so it's there. Okay. Ooh, Cloud Connector. We talked a little bit about this, right? We've already talked about virtual. Think about, I've got a virtual firewall. Think about what functionality that would have. I've got the greatest router on earth, an MX router and a virtual platform. I've got to connect my data centers, right? Remember, I'm a hybrid kind of cloud. I'm a hybrid cloud, right? We've got some private stuff over here, Buddy Rowe. Nobody can see that. Right, but we run the front end over here in Amazon Web Services. So that web server needs to connect back to our corporate headquarters data center and talk to the database server so we can populate those web pages with the correct with your account information, Jimmy Bank, right? And so how do I connect that? Well, heck, at the corporate headquarters we've got an SRX firewall, physical firewall. One of them awesome MX routers, physical device. And from there, I can build tunnels back to the VMX and the VSRX running in the cloud. There's no difference in functionality between the physical and virtual platforms, right? So yeah, okay, well, between this VSRX and build an IPsec tunnel, so our traffic's encrypted and hashed and all that kind of fun business. And then I'll build the actual, EVPN tunnel, layer 2 VPN between, this VMX and this MX, so I can get my web server and my database server on the same subnet. Isn't that something? Magic. So that's what we can do between, these virtual, physical, it doesn't matter. All the functionality is the same. So think about how you use these, right? You'll be required to know that. Hey, let's do it again. Hey, it worked so well the first time. Hey, let's start hosting our apps in a different cloud, the Microsoft Azure cloud. They sell VSRX and VMX too, right? So, I mean, that's the idea, right? Once I learn how to do it, I can replicate this. And just like push the button, push the button, push the button, it's fast. It's automated, right? We'll be up in hours. All right, that's chapter 3, right? The virtualized VSRX, VMX, NFX 250, a high level on the NFX 250, right? How are these things used, right? Well, I've got a firewall and I've got the world's greatest router. I mean, how else? Think of the possibilities here, right? I can connect all my branch offices together using this cloud. This is great. Right? We talked about the Cloud Connector. Okay, so a couple of things there. All right, that's chapter, what was that, 3? Let's go to chapter 4. This is our last one today, if that makes you feel a little better. And this is going to go over something called SDN. SDN fundamentals. So we're doing great. I appreciate you being here. You're doing a good job. It's interesting content. Read this week, right? SDN fundamentals. So we're going to talk about what is SDN, what are the parts, how does it work, how is it used. That's what we're going for here. SDN. We know how to spell it. So what's the need? Why do we need this SDN? Well, because look, networks, man, we've been talking about just punch the button, man. It'll spin these servers up like nobody's business. But the networking devices don't work that way. They aren't into this automation business. These are separate physical devices, appliances, right? And I've got to configure every single one of them individually. And if I want to add new services, I've got to touch every one of those jabronis. That's going to take forever. I'm going to make mistakes. We're going to have an outage. Problems. Oh, I'm sorry. Please don't break my network. All right? So we've got to change that, right? Look, I'm spinning up these virtual services, but I can't manually build these networks to connect them all. That's the kink in the hose here. This is what's keeping us from making money. And so, just adding more and more of these, whoops, I'm sorry, I went too fast. More and more of these devices is just really making the situation worse as we grow, right? There's got to be a better way, right? Another problem that we've got is each device, well, from the Department of Redundancy Department, each device has to be managed individually. Each device has its own control plane, has to do its own learning, has to be configured individually, right? Just to forward traffic. That's all I need. But I've got to tell them all individually. They all have to figure it out how to forward traffic. Wow. So, and it doesn't always work. With just the same problem we had with buying these $10,000 servers and putting one OS and one application on there, we're having the same problem with these networking components. I've got to buy this very expensive component, and I'm not really using all of there's got to be a better way. Just got to be a better way. Right? So in the ideal world, and that's what we're shooting for, right? We're always chasing this. I need this to be just like any cloud service would be. I need it to be automated. I need it to be fast. I need it to be, controlled by the push of a button. I need it to let me know how it's going on, what's going on, right? How are things perform? That's what I need. That'd make me sleep better at night. How about you? So let's talk about SDN. So somebody try to figure this out. And so, what is SDN, right? It's a new way of doing things. And we're going to see in a couple of slides how this works, but we're trying to tackle some of the challenges we're having, with the way things work now. We need things to work more like they do with virtual servers in cloud environments, right? And so the Open Network Foundation created a definition of something called software-defined network. And the big piece of it is I want to separate the control plane from the forwarding plane elements. And I want that control plane that I separate out, I want to centralize it on something called an SDN controller. So the SDN controller is the one central brain. It's the one component that learns everything about the network, bandwidth and metrics, and learns all that. And that centralized SDN controller can compute the forwarding paths and then distribute those forwarding paths out to more or less complex forwarding plane devices. I don't need the forwarding plane devices to really have a high-performance control plane in them anymore, because I'm going to take that away from them and centralize it and centrally manage my network, centrally configure my network. That's what an SDN controller does. So separation of the control plane, centralization of the control plane from the forwarding plane, right? So the forwarding plane is the worker bees. So again, separation of planes, centralize the control plane. I want these devices to be programmable, so I can do this in a dynamic, agile, quick-to-market fashion, right? Open standards, man, this is going to be the greatest thing. I'm going to save some money from this, you watch. Okay. So there's 4 planes, kind of, and not all devices have all these planes, but we've already talked about the control plane and the forwarding plane. All kind of networking devices have that. Somebody's got to be the brain to figure out how to forward traffic, and then somebody's actually got to forward it, right? So 2 separate components. There's a management plane. How do I manage this device? How do I connect to it, configure it, monitor it, right? And then maybe there's a services plane. This is an SRX firewall. So it's got a control plane and a forwarding plane, and there's a whole gaggle of services that it offers. Firewalling, IDPing, NATing, all that kind of. Those are certain. Not all devices have that plane, right? But we're trying to completely separate these components so we can optimize how they function in the cloud network. That's the ideas, right? So again, centralization. I want to take the control plane from the individual network components and centralize that on an SDN controller. So I have one component that knows everything about the network, can compute the best forwarding pass through the network, and then communicate the forwarding pass out to the forwarding plane components that just forward ones and zeros around in an optimized fashion, in a dynamic optimized fashion, I should say. So the SDN controller has the big picture view of the network. Right? And that SDN controller, that's a great thing. But, I don't really like to get in there and configure it manually. We've got an application that we use. We've got a portal that customers go to, and they say, hey, I need to connect the Denver office to the Sao Paulo office. I need this much bandwidth. I need, this level of high availability, this level of service, and they hit submit. And so some application, some website, spits out some instructions using an API that the SDN controller supports, and then that SDN controller computes how that tunnel should be signaled through the WAN or through the data center, right? And signals that out to those forwarding components in an automated fashion. Nobody has to physically touch the networking components. It's all done dynamically. And that's the idea, centralization, right? And so, flex savings, flexibility, I can do this really quick. I can let some of these Freds and Sallys go because we don't need all these people to manually configure these devices anymore. Just saves me money, right? That's what this is all about. Better utilize my resources, right? Faster to market. Teeth are wider, kind of stuff. And eventually this is supposed to be like a living, breathing thing. So, we orchestrate all these resources, the compute and the storage. We spin up the virtual network. Everything's automated, right? All done through software. And then, those components, once you spin it up, it reports things back. Here's how I'm performing. Here's any type of alerts and events and logs. And then we have machine learning running analytics on that data, and feeding back into the system so we can dynamically, let's reroute that tunnel. Let's move that virtual machine over to another physical server or data center because it's not meeting the service level agreements. It's supposed to be a living, breathing, automated thing eventually. That's what we're trying to get to. Right, and the present status, it's kind of a standard, so everybody messes up the standard to make it work better with their products, their technologies, and so there's kind of been some tweaks of what different people think SDN is supposed to be. So let's kind of look at that going forward. And SDN, we're going to look at it in this instance in the data center, and then more toward the end of this chapter, we're going to look at SDN and how it works in WAN environments and some of the solutions there. And so, here's the SDN. Here's kind of an environment, right? Software-defined networking environment. Here's my SDN controller. That's the, and from the department of redundancy department, I've got to have at least 2 of them so I can sync the config and sync state in case one of them gets hit with a milk truck or something. And so, here's my controllers. This is what can dynamically program these forwarding elements to connect these hosts and servers in my cloud, right? And so I've got some kind of application, some orchestration system like OpenStack or a web portal people go to. And they say, hey, I want this type of service, I need this type of connectivity, submit. And that information gets passed down to the SDN controller who can convert that application's instructions into something the forwarding components can understand. Hey, forwarding component A, B, and C, build this type of tunnel here, and so we can connect this virtual machine, this host and the server together. So the application works. So that's the role of the SDN controller. So I will probably have an application front end, fill out this form, submit, goes to the SDN controller, who would then speak, I don't know, Junos, right? They can push that out to these Junos forwarding elements out there. That's the idea, right? So there's a northbound interface, southbound interface, and it's the SDN controller is kind of the middleman here, right? Translator. Oh, there's the, sync your state, sync your config, in case we lose one, your job. Right. Now we're going to talk about something called OpenFlow, right? Let me see if I can show you something here. Okay. Let me show you OpenFlow, right? So here's the SDN controller, and here's the web portal or the OpenStack or whatever that says I need this compute, this storage, and this network, and that request gets passed to the SDN controller. And in this case, this SDN controller uses OpenFlow as the protocol that's used to communicate, hey, build this tunnel, Mr. Forwarding Element, build this tunnel, Mr. Forwarding Element, build these tunnels, right? That's what I need. So The protocol that's used between the SDN controller is something called OpenFlow. It's kind of a standard protocol, that's supported by, multiple vendors out there, right? And so we can move from the static manual configuration process to centralize the control plane on an SDN controller, and we communicate to the forwarding plane devices using OpenFlow. That's great. Standard way it's done, right? And so, the forwarding plane is now programmable. That's the idea. That's why I have this SDN controller. And simply, again, the communication out to the forwarding elements is something called OpenFlow. That's the idea, right? And here's the Juniper platforms that support this. Juniper has an SDN controller, but it doesn't use OpenFlow to communicate with the forwarding plane devices. But these Juniper forwarding plane devices can work with anybody's OpenFlow controller. If that's what you already have, right? Well, we've got an SDN controller, but it only speaks OpenFlow. Well, then these Juniper platform will work for you, and this list changes all the time, right? So these versions of hardware with they work with OpenFlow. Plug your controller into it, your SDN controller into it, right? As an overlay, right? We're back in the cloud world. SDN is an overlay, right? We've got our underlay network. There's nothing different here. That's been racked and cabled a long time ago. That's done, right? But then we do an overlay network, right? And that's where we spin up the compute virtual machines, the storage, and then we need to connect those virtual machines and the storage together with a overlay network, right? The virtual tunnels, that are created to dynamically connect all those virtual machines together that make the customer's application work, right? And so, we need to build these overlay tunnels. It can be based on MPLS. It can be based on VXLAN. There's a lot of different technologies, a couple different types of technologies that can be used to build the overlay networks that connect the customer's virtual applications together, right? So here's in the data center, right? We're going to use SDN. So here's my SDN controller, right? And we'll look at customer green here, VMX-A1 and VMX-A2 that are running on different physical servers in this cloud environment. So VMX-A1 may be the web server and VMX-A2 is the database. They've got to talk, right? But when they spun up, they're spun up on different. How do I do that? Well, they're all running on a hypervisor. So what I can do, let me see if this is animated. I can't remember, right? Yeah, it is. So my SDN controller can install a network plugin in the hypervisor that these virtual machines are using. And the SDN controller, once these virtual machines are spun up, can dynamically configure that network plugin to establish a virtual tunnel, maybe a VXLAN tunnel, that connects those two virtual machines together. Same way with customer red, right? Or maybe some type of pink. I'm not very good with colors, right? Customer B. Right? We can dynamically program those hypervisors and build dynamic tunnels on the fly. So spin up the virtual machine, and I'll dynamically, with my SDN controller, spin up the virtual network that connects them together. Okay. Oh, and I'm sorry, the SDN controller that can do that in your data center is one called Contrail. And we'll talk about Contrail in a later module. We'll talk about it a little bit here today, but we'll talk about it more deeply in one of our next two sessions together. We'll go over Contrail. Hey, here's Contrail. Contrail is Juniper's SDN controller designed to work in data center cloud environments, right? And so in data center cloud environments, you have an orchestration system that's commonly software called OpenStack that can dynamically spin up the compute resources when a client, hey, I need these virtual servers, I need this much storage. It can dynamically instantiate the virtual machines, dynamically instantiate the storage, and dynamically create the network that would be used, the overlay network that needs to be dynamically created to connect those components together. Connect the customer's virtual machines and the storage together, right? And so what the OpenStack orchestrator can do is send out a call through a plugin called the Neutron plugin saying, hey, I need this network built to connect these virtual machines together. And that gets passed to the Contrail SDN controller, who can then, on the hypervisor that those virtual machines run on, install a Contrail virtual router, and in that virtual router configure the overlay tunnels that connect those customer virtual machines together, right? Dynamically, automatically, on the fly. So it integrates with an orchestration system, compute, storage, network. That's where the SDN, the Contrail SDN controller comes in. It dynamically signals the overlay network to connect the compute and storage together, right? Cool stuff, right? Need to know this. There's kind of 3 different versions of Contrail we're going to talk about. There's the open Contrail, free open source software. Hey, go out it, get it, compile it, install it, build it all yourself. You're good at this, right? Or you can go to Juniper Networks and you can buy Contrail Networking, which is a Juniper-supported version of Contrail, right? And so you've got OpenStack set up as your orchestrator and you need Contrail as your SDN controller. Juniper will sell you a version of Contrail and we'll support it. We'll help you integrate it, right? Or you can buy the whole thing from us. We have a Contrail Cloud offering where it's, we'll sell you and support both OpenStack and the Contrail SDN controller component. So we can help you automate your entire data center, your entire cloud environment using Contrail Cloud. So it depends on your level of expertise and how you want to build your cloud network, but we can help. Right, SDN via API. This is a, well, yeah, we support SDN. I'll tell you what. Well, there's different ways. A salesperson can say a lot of things, but some people will say they offer SDN, but it's not really probably true to the true pure definition of how SDN is supposed to work. We can program the control plane, but we don't have it centralized. So you may have 100 of our appliances, but we've got an application that you can run and centrally manage all those, but you still have these distributed control planes out there. It's not like the true centralized SDN brain controller here, right? And so we connect out to our devices using, secure shell, and we centrally push out configs, right? And that works because that's what we've got today, right? We've got too many to manage individually. This is our best solution today. But over time, we might want to migrate more to a true, SDN-defined environment. So, I still have multiple devices out there, right? But I've got some type of centralized management system. But it still has a control plane on each of the devices that has to do learning, and it's individual device learning, right? An individual device's view of a network versus an SDN controller with a network-wide view of how the network is structured and performing. So it's kind of SDN, but we're just using APIs to call out to the devices. So it's not really the true definition. And you can do that in Juniper devices. You can do that through a protocol called netconf. Your centralized management system can connect out using secure shell and use XML or Yang to push out configuration and pull back information from Juniper platforms. We also have something called a REST API, which is an HTTP way. All the different configuration objects are presented as URLs, and we can write a web page, a web app that can manage these devices centrally. Again, it's not true SDN because I'm still managing all these distributed control planes, right? It'd be a lot more efficient if I managed one centralized control plane. It'd save me money in the long term. Then I don't have to put those expensive control planes in all these forwarding plane devices, right? And I get a better picture of my network. If you're writing applications for Junos platforms, there's also something called the Junos Extension Toolkit. It's an additional set of libraries that you can add into Junos that allows developers to write third-party applications that will run directly on Juniper platforms, run inside of Junos, right? So, we like Junos. It does everything we want except this. Well, there's ways to extend the functionality of Junos platforms using this toolkit, right? If you're, an application development company, you might do that. Just like people write applications that run on Windows, right? So, applications of SDN, couple different things. We mentioned, we've kind of looked at SDN from a data center perspective. I'm spinning up these virtual machines and these storage, and I need to connect them together with these overlay networks. That's what we've looked at an SDN controller. They can also be used in WAN environments, right? Because I don't really run a cloud here, right? But I sell WAN services like crazy. I'm the king of the Midwest, WAN service-wise, And so, what I need to be able to do is have a customer come to a website and say, I've got an office in Denver and I've got an office in Phoenix, and I need to connect them together. How long is this going to take? Oh man, hey look, just go fill out this form. Tell me what you want, what type of speed, the amount of bandwidth, what type of redundancy you require, any security services while you're here. We sell security. How about you fire? Do you need to IPsec that? You need to do any natting? How about any kind of load balancing you're looking for? I've got a great deal on load balancing, right? And so they can go fill out a form on a portal, kabang, hit submit, and I can dynamically configure the edge routers that my customer sites are connected to build tunnels, MPLS tunnels, to connect their remote sites together. I can dynamically build WANs, sell MPLS services in a dynamic fashion, in an automated fashion to my customers. I'm somebody, right? And I can use SDN for this, right? And that's the whole deal. And so, if I'm selling lands, what do I need to do? I need to maximize the use of my resources. I need things to be routed in the most, efficient fashion, most highly redundant fashion. I've got service level agreements here. That's why I can't sleep at night. And so, this is the type of stuff I need to sell, the services I need to offer. Right? So Juniper has an SDN controller that can do that for you. It's called North Star. Now we'll talk a little bit more about North Star, I think, in another module that we'll go over here in one of our next couple of sessions. But it is an SDN controller that can dynamically signal label switch paths across a service provider WAN network. And so a customer submits a ticket, I can go into North Star and I can say I need an MPLS tunnel between this node and that node. I need these types of service levels, this type of redundancy, this amount of bandwidth, and submit, and it is dynamically instantiated. I don't have to physically touch any device on my network. I use this centralized North Star controller who knows everything about my network, right? Because he's paired with my network devices, and it gives me true software-defined networking capabilities. A centralized control plane that can dynamically program this distributed forwarding planes on my network to build WAN services on demand. That's the idea here, right? So some of the features, I'm going to go through these really quick. I mean, you're going to go back and read through this. I don't need you to know every single feature about North Star, but it can learn about your network. It peers generally using BGP with one of the service providers' WAN routers, and it learns all of the links in the network, all of the bandwidth, all of the tunnels that have been signaled. It peers with the provider edge routers using a protocol called Path Computation Element Protocol, learns about tunnels that already exist, uses this to signal new tunnels, receive status information about network performance, right? So it can do everything. It can discover existing tunnels that are on the WAN, provision new ones, monitor them, modify them. It's a very flexible and elastic way to manage MPLS tunnels across a service provider WAN in a centralized automated fashion. This is great, man. I can schedule label switch paths to be torn down. The customer, between the Denver and the Phoenix office, we've got a label switch path. They're doing a big migration this weekend, need more bandwidth, and so, we're going to, kind of temporarily signal an additional label switch path that they can use to increase their bandwidth. And then when the weekend's over and the migration's done, we can tear that down for them, just in a flash. I don't have to physically touch these routers. It's all automatic because I've got a North Star SDN control, right? I can signal primary paths, secondary paths, any functionality of MPLS I can signal using the North Star controller dynamically, right? These are the services I'm selling, right? Holy smokes, I've got to take that router there out of service, this weekend. What about the tunnels that are going across it? I can schedule maintenance on a device, and North Star can dynamically compute alternate paths for all of the LSPs that traverse the affected router, so I can take it offline, do a software upgrade, put it back in service, right? All without affecting traffic. This is cool. This is dynamic. Think if you have to do that manually, reconfigure metrics, and it'd take a while, right? And there's another platform or another product that Juniper offers that really helps you study your network and optimize your network, analyze how it's performing today, and see how you could optimize your network to maybe maximize resource utilization, put off costly hardware upgrades. And it's something called WANDL, IP MPLS View. And it is used to build a model of your production WAN network. You can import configuration, operational mode statistics from devices, and use that to build an offline model of your production network. And so now I've got an offline model of my production WAN. And so what I can do with that then is, here's all the tunnels traversing it now. Here's how much bandwidth is used. What would happen if we added another node? What would happen if we move this link from that node to that node? What happens if we change the metric on this thing? What happens if we had to add 10 more tunnels and the Denver router went down? I can simulate all of these activities in an offline model of my network and analyze how those activities affect my network, so I know beforehand how those same things would function on my production network. Hey, how about we add a new link? Well, what would that do? Which tunnels would start using it? How much kind of benefit? I can figure that out before I actually do it using IP MPLS View. So it's an offline network analysis tool. It's incredibly powerful, right? So that's another, something that might help you optimize your WAN environment, right? And that's when it's used. What would happen if, I can model my network, I can simulate outages. What would happen if we added more links, added more powerful, more bandwidth, or we changed these? Well, what would happen? right? And I can do all of this in an offline model of my WAN, so I don't have to tinker with production. And that's the idea of this. All right. Now, software-defined WAN, right? This goes back to the NFX 250 platform. That, this is going to be my customer premise equipment device. So when customer X signs up, I'm going to drop ship you this NFX 250 platform. Just plug it in. We've got a, existing point of presence here. Just plug this cable in, and I will be able to reach out to that NFX 250 and program that dynamically in an automated fashion with whatever the services the customer subscribed for. We need internet access. We need this routing functionality so we can route, OSPF to our remote sites. And so let me push down a VMX, and let me push down a VSRX out to that NFX 250 so they get their NATing, their firewalling, their IPsec, and the MX is doing the routing for them and the MPLS connectivity. Right, that's the whole software-defined WAN thing. That's what the NFX 250. I'm going to send that out to that branch site, and so they can connect back to the VMX or physical MX running at the enterprise data center, and I can dynamically program that NFX 250 with whatever type of connectivity services. That, you need MPLS? Okay, well, cool. I'll push down a VMX to that NFX 250, and it can build an MPLS tunnel back to the physical MX in our enterprise data center, right? And they can pick all this, what services they want. I want SRX, I want firewall services, I need this type of connectivity, and I would dynamically push whatever VMs, whatever services need to be configured out to that NFX 250, that remote branch site. So that's kind of a software-defined WAN. I don't have to send somebody out there with a truck and a bag with a console cable, and it's going to be a couple weeks because Fred's on vacation, right? We can do this in an automated, dynamic fashion centrally, right, from the enterprise data center or from the service provider side of things. We don't have to physically go touch anything, right? All right, that's it for, chapter 4, right? And that's our work for this week. That's our entire content review. Next week, I want you to show up prepared because we're going to review Module 5, Module 6, Module 7, right? And it goes fast, doesn't it? I've only got 90 minutes to get through a day's worth of training. So I need you to take the time to go through that and bring a bag of questions. So when you show up here next week, I want to see smoke coming out of that chat window, right? I want everybody, Gordon, Mark, Lawrence, this question, that question, right? Because we're here to benefit you. You need to get this JNCIA cloud certification. And so to be successful, remember, one of the lessons is you've got to prepare for this, okay? So that's about all I've got to say, right? I want to thank Mark for driving this chat window here. He's incredible. He does a great job of doing that. I want to turn things back over to Lawrence now, and he can have some final words. But thank you, everybody, for taking the time to participate. I will see you here next week, right? Get into the forum. Get into the forum. Get into the forum. Thank you. I'm sorry, Lawrence, for babbling on. Your turn.
No worries, Gordon. Babbling on is good. Hey, I don't have any tremendous... now I'm breath. You got that right. No other tremendous words of wisdom here other than... like Gordon said, work your way through that material. There's a lot of acronyms, a lot of things to learn. And please, please, please show up next week. Same time. You can do it either 7 in the morning or 4 o'clock in the afternoon. Those are Pacific times. Translate that to your local region. And if you try and get in too early, it may give you a warning saying there's not enough room. That's just the error that Adobe Connect provides. If you get in more than half an hour early, it'll start serving up that area. So, just get on a couple minutes ahead of time, think of your questions, start going through the material. Certainly, if you want access to that private forum on JNet, you can send your JNet ID to education-services@juniper.net. And if you are officially registered for this open learning session and you haven't yet accessed the course materials, you'll need to let us know your Junos Genius ID. Apologies for all the different IDs. But Junos Genius ID goes to Junos-Genius@juniper.net, and we'll square you away from that. So that's all I've got. Unless there's any final questions coming in the chat window, we'll go ahead and close it out and pick it back up exactly 1 week today, next Wednesday. Thanks, everyone.